Okay, let's dive straight into this explainer and crack the code on exactly what Cambridge examiners are aggressively looking for in the Information Technology 9626 syllabus. I want you to think of yourself not just as a student, but as a paleontologist. Seriously, stay with me here. When you sit down, open that booklet and approach a complex exam paper, particularly in Cambridge computer science and IT, you are essentially staring at a site waiting to be excavated. You are digging through fossil layers, and those layers are the intricate, often confusing, different parts of the question. Your job? To carefully extract every single bone and piece them together to reconstruct the full, perfect dinosaur, or in our case, the absolute top-tier, full-mark answer. To see where things go wrong, take a look at this real Cambridge past paper question we've pulled up. We've got two different students tackling it under exam conditions. Meet Alex on the left. Alex completely overloads the page with raw computer science facts about data-driven AI. He writes a massive, dense block of text outlining exactly how neural networks function, but he includes absolutely zero analysis of the actual scenario. It's just a data dump. Now look on the right. We have Sam. The clock is ticking. Sam rushes through the exam, panics about the time, and completely misses the specific command word requirements. He writes a conclusion when he was supposed to evaluate. Look at those heavy red pen marks slashing through both of their answers. Today, we are going to fix this. We are going to reconstruct those answers layer by microscopic layer and transform those brutal red marks into glorious green check marks. Welcome to your ultimate Cambridge exam strategy masterclass.
I really want to start our session by asking a crucial, fundamental question, because we see incredibly smart, capable students struggling with the exact same distinction between key terminology in this specific topic time and time again. Why on earth do so many students lose easy marks on AI and data-driven topics? Whether you are sitting for the 0417, 0478, 2210, 9618, or the 9626 syllabus, the trap is entirely identical. Topic 7.1, Data-Driven and Goal-Driven AI, which covers complex things like medical diagnoses, pathfinding in gaming, and AI for social media, sounds deceptively simple. It sounds familiar, right? You interact with sophisticated social media algorithms every single day. You play incredibly complex video games. So, when you sit in that exam hall, it feels incredibly easy, almost natural, to just write down your personal, everyday experiences. But as Alex and Sam's deeply flawed answers prove, your personal experience does not earn Cambridge marks. Examiners are absolutely not asking for a casual conversation about your TikTok feed or your gaming habits. They are testing your ability to apply a highly specific, rigorous academic framework. Alex lost his marks because he brain-dumped technical jargon without linking it to the specific goal-driven diagnosis scenario in the prompt. He gave a textbook definition when they asked for an applied solution. Sam lost his marks because he completely ignored the structural requirements demanded by the command word. This explainer is going to show you exactly, step by step, how to avoid their fate.
To get us there, we are breaking this entire topic down into a heavily structured roadmap. First up, we'll decode the core cognitive domains. Second, we'll master the deconstruct, solve, evaluate method. Third, we'll drill into the technical presentation conventions you absolutely must use. And finally, we'll reveal the top examiner warnings straight from the Cambridge grading rooms. Let's get into it.
Section 1. The core cognitive domains. It is time to uncover what examiners actually test when they read your paper.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's look at this brilliantly illustrated table. To master these cognitive domains, you need to understand exactly what command words are asking you to do. The academic benchmarks in Cambridge syllabuses ruthlessly prioritize logical, structured reasoning and analytical depth over a superficial breadth of knowledge. It is not about how many buzzwords you know, it is about how deeply you can dissect them. First, we have knowledge and understanding. This is your foundational bedrock. It's your fundamental grasp of what data-driven versus goal-driven AI actually is. Next is application. This is where most students stumble. Application is your ability to take that foundational knowledge and apply it to a completely unfamiliar context. Imagine the paper throws a brand new social media algorithm at you that you've literally never studied before. Can you adapt? And finally, the holy grail, analysis. This requires you to weigh the pros and cons, examining the implications using incredible analytical depth. Think back to Alex's purely factual data dump versus Sam's panicked, rushed answer. Which one of them successfully hit the analysis domain? Neither of them did. They barely scraped past knowledge. To break into that analysis column and secure the top marks, you have to change the way you structure your thoughts entirely.
So, the absolutely crucial point here is that you must demonstrate a connected conceptual mastery that you can adapt to any completely new scenario the exam decides to throw at you. You aren't just memorizing dictionary definitions of machine learning, you are learning a flexible system of thinking. Top students use what we call the Peel framework: point, evidence, explanation, link. You must structure your answer logically. When you truly understand the underlying concept of how data-driven AI trains on massive historical data sets to identify predictive patterns in a gaming environment, you can take that exact same conceptual understanding and seamlessly transfer it to a question about how an AI identifies credit card fraud in banking. It is the exact same underlying mechanics. You are just looking at a different fossil layer to dig through. The Peel framework forces you to state your point, provide evidence from the prompt, explain the technical computer science mechanism, and link it back to the specific outcome required.
Moving on to Section 2, the Deconstruct, Solve, Evaluate method. This is where we focus heavily on executing what I like to call the method mark strategy. Listen closely, because in Cambridge computer science and IT papers, examiners often award method marks. What does that mean for you? It means even if your final conclusion at the very bottom of the page is slightly off, you can still secure the vast majority of the points if your analytical process is mathematically and logically sound. When you are tackling complex, multi-part problems about goal-driven medical diagnoses or adaptive gaming algorithms, you must systematically use this Deconstruct, Solve, Evaluate framework. Let's break it down. Step 1, identify given information. Step 2, break the problem into logical steps. Step 3, solve systematically. Step 4, check for reasonableness. And Step 5, make justified recommendations. Let's see this transformation in real time. We are going to put Sam through a live rewrite. Watch as Sam takes his previously vague, panicked answer about gaming AI and applies these 5 distinct steps. Imagine a 60-second timer ticking down. Instead of just writing "the AI gets harder," which earns 0 marks, Sam now identifies the given information, the player's win-loss ratio. He breaks it into logical steps. The data-driven AI dynamically adjusts the enemy's health parameters based on that specific win-loss data. By solving systematically and ending with a justified recommendation about server load, Sam's answer just went from an absolute 0 to a perfect top-tier score. He showed his work. He showed his method.
Now, to truly achieve that coveted analytical depth, you must embrace comparative analysis. What's really fascinating about this slide is how it visually highlights the strict requirement for comparative connectives. You have to draw firm conclusions about relative importance. On the right side, we see Alex's typical fatal mistake, just listing standalone facts. He writes, data-driven AI uses large datasets. Goal-driven AI uses rules. Boom, full stop. Let me be clear, that is simply not good enough for Cambridge. To reach the highest tier of the mark scheme, you must migrate to the left side of this screen. You absolutely need to identify similarities and differences using comparative connectives, like whereas, conversely, or on the other hand. You need to construct a sentence that sounds like this. Data-driven AI identifies emergent patterns from vast historical datasets, whereas goal-driven AI navigates toward a highly specific outcome using predefined expert rules, making goal-driven AI significantly more suitable for deterministic environments like a chess engine. Do you hear the difference? That is analytical depth. That is exactly how you absolutely dominate the exam and secure those final grade boundaries. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are now entering Section 3, Technical Presentation Conventions. Let's talk about formatting for absolute professional success. We are moving into our interactive workshop phase. If you want top marks, you must rigorously, without exception, follow these strict conventions when extracting relevant data and selecting your analytical framework. The syllabus states explicitly that practical application develops professional skills. Let's do Challenge 1, the data scan. Imagine I just put a complex data table on the screen showing the performance metrics of a brand new social media AI sorting algorithm. You have a 60-second visual countdown timer in your head. Your task is to extract the core trend. Go.
Time's up. If you just wrote down, "the speed goes up," you failed the challenge. You must use correct terminology like algorithmic efficiency or data throughput. You must apply proper headings to your final structured answer, provide clear, concise annotations explaining your underlying logic, and ultimately evaluate the overall performance of the algorithm based strictly on the data provided in the table. If you ignore these bullet points on screen right now, the examiner will simply stop reading, no matter how brilliant your underlying textbook knowledge is. Presentation is part of the grade.
Let's move to Section 4, Top Examiner Warnings. These are the golden insights pulled directly from the Cambridge Principal Examiner reports. Pay very close attention because these are the exact traps you need to avoid. The examiners literally publish reports every single year telling us exactly what goes wrong across the globe, yet thousands of students continue to make the exact same unforced errors. Let's jump into Challenge 2, Find the Flaw. I'm going to read you a sample paragraph, and you have to identify the sentence losing marks. Here it is. The AI for the new hospital system is good because it processes data fast and helps doctors make choices. Did you spot the flaw? Let's look at the examiner commentary. That sentence actually violently hits mistake 1 and mistake 3 simultaneously. It is far too vague. What specific medical data? How fast is the processing time? What kind of choices? And worse, it is completely devoid of context. It doesn't mention the specific goal-driven diagnostic mechanics that the hospital prompt was actually asking about. Examiners want specific, technical details. Precision is the ultimate currency in Cambridge IT exams.
Let's look at the stark visual difference here, which brings us to Challenge 3, Speed Writing. You have 30 seconds to write one perfect Peel paragraph in your head. Your goal isn't to write a generic, perfectly memorized fact like Alex did on the left side of the screen. Your evidence and your explanation must map directly to the scenario, as beautifully shown on the right side. If the exam prompt is about a social media company using AI to filter inappropriate content, your answer absolutely cannot be a generic rant about how AI plays chess or drives cars. You must specifically state how the AI analyzes text sentiment, how it flags specific restricted keywords, and how it learns from user reporting data to dynamically refine its filtering goals. That is what we call a context-specific answer. That is how you prove to the examiner beyond a shadow of a doubt that you haven't just memorized a textbook, but that you actually understand how to solve complex, real-world technology problems.
Please, do me a huge favor and etch this exact quote permanently into your memory. Linking every single point to the given scenario is the absolute, undisputed golden rule of Topic 7.1. This isn't just my opinion as a strategist, this is a direct, word-for-word examiner alert pulled from the principal examiner reports. When you finally sit down in that exam hall, I want you to take your pen and write this on the top corner of your scratch paper. Always link to the scenario. If you write a brilliant, technically flawless, structurally perfect paragraph about the hidden layers of neural networks, but the question was actually asking about a simple, rule-based expert system for diagnosing car engine faults, you will get 0 marks. 0, nothing. You have to tailor your incredible technical knowledge to the precise constraints of the situation. Every point needs a link, it's the L in the Peel framework, and it's the anchor that secures your high grade.
Now, how do we remember all of this under intense pressure? Let's introduce the visual story method, an incredible memory hack designed specifically for Topic 7.1. By grouping these rigorous, sometimes dry syllabus requirements into a vibrant visual story, you can rapidly and easily retrieve the proper analytical frameworks under extreme exam pressure. We are looking at a complete computer science answering system here. Think of the 3 rules that absolutely guarantee top marks. Rule 1 is command word decoding. Rule 2 is Peel framework application. Rule 3 is the time management matrix. Now let's build a visual story around them to lock it into your brain. Imagine a brilliant doctor, a hardcore gamer, and a viral social media influencer all walking into the same room. The doctor uses data-driven AI to look at thousands of past X-rays. That perfectly represents your historical data pattern recognition. The gamer is fighting a massive boss that uses goal-driven AI to actively block his specific, real-time attacks. That represents your rules-based outcome targeting. And the influencer is watching an algorithm dynamically change her feed based on the exact millisecond she hovers over a post. That's your continuous feedback loop. When you connect these highly abstract computer science concepts to vivid visual characters in a narrative, your cognitive load drops significantly. You aren't desperately sweating trying to remember a textbook definition. You are just recalling a simple, engaging story. And suddenly, writing that perfect, context-specific analysis using the Peel method becomes total second nature. So, the ultimate question, are you ready to apply the Deconstruct, Solve, Evaluate framework to a completely unfamiliar AI scenario in your next past paper? Knowing the strategy is absolutely not the same as executing it. Now that you have the complete insider blueprint to the examiner's mind, the only thing left to do is dive into a past paper and prove you can secure every single method mark available. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.